Hi, my name is Ben, and today we're going to be learning about mathematics in the Dark Ages. I chose this photo for my cover because it's called the God the Geometrist, and I used that because the church was such a heavy influence during this time period in the decisions of what the public was able to know, and they believed that math did in fact come from God. So that's why I chose that picture. So when and where did this take place? Well, the Dark Ages actually often refers to the bulk of the Middle Ages, and it was roughly between the 6th and the 13th centuries. It occurred in Western Europe, and it was after the decline of the Roman Empire. And the Dark Ages were not entirely dark, you would say. The term is in question because many historians today have found a lot of evidence that refutes that it was a complete and utter disparity. But um, it was used because it referred to the cultural and economic decline that supposedly occurred in Western Europe after the fall of the Roman Empire. And it was originally intended to denote the entire period between the fall of Rome and the Renaissance, or the period of classical antiquity and the modern era. And historians rarely use that term today, and they usually just use Middle Ages. The church was a huge part of the culture in Western Europe during this time. It was the only accepted form of Christianity, and the Roman Catholic Church was the only universal European institution during the early Middle Ages. It had a huge influence on what people could, or in this case, couldn't learn. In this picture, there have a statue of Jesus. Um, it depicts it toppling over a Greek statue, and it's supposed to represent Jesus, like the church breaking out different pagan beliefs such as mathematics. So Greek mathematics were actually considered pagan during this time, so they were banned, and no one actually was able to learn about them. And the church and the scholars turned their attention to the study of theological issues rather than physical sciences and mathematics. And this um, was a big problem because most of the public didn't actually know very much about anything, especially mathematics. And barbarian invasions continued throughout Western Europe through the 5th and to the 11th centuries, and it brought much instability to the region. It marked a serious low point in the development of mathematics. The 7th century was said to be one of the worst, resulting in nearly stagnant advancements in mathematics, science, and philosophy at all. And because the church ruled for most of this time period, much knowledge was lost and kept ill-preserved. However, there was a different part of the world at this time that did end up preserving a lot of this information, and that was the Byzantine Empire. The Byzantine Empire remained independent and isolated from much of Western Europe. They kept the Greek learning and studies alive, but they kept it dormant, so they preserved it. And through preserving these documents, they were able to actually help start the later Renaissance. They also actually worked and translated Arabic texts on Islamic astronomy, mathematics, sciences, and they translated it into medieval Greek, including the works of Jafar ibn Muhammad Abu Musa al-Khwarizmi. So monasteries were actually one of the only places education was allowed. The monks there were taught elements of reading and writing in Latin and biblical studies. However, they were still suspicious of Greek authors as pagan, so they did not learn anything in the forms of mathematics. They eventually started preserving old documents and Greek teachings like the Byzantines. However, during this time period, um, a new power actually arose, and they began to learn the ways of mathematics. And those were the Arabians. And the rise of Islam and mathematics can actually be seen going hand in hand. The Islamic faith was spreading, and it united many of the desert Arabian tribes. The powers actually spread throughout some of the Mediterranean and as far as up to Spain and parts of France. Arab scholars ended up setting up a place called the House of Wisdom, and it was set up by the Islamic faith to preserve and study stuff, including scripts and documents from Greece. I mentioned this guy before, Musa al-Khwarizmi. He was a very important figure when it came to mathematics during this time period. He assisted in a project that actually determined the circumference of the Earth and in making a world map for Al-Mu'min, the caliph, and it oversaw 70 different geographers. Al-Khwarizmi actually was huge when it came to the advancement of algebra and trigonometry as well. And his name actually renders as algorithmi in Latin, and this is where the term algorithm comes from. So his name actually derives the word algorithm, which I thought was pretty cool. He also helped write this huge book. This is the translated title, The Compendious Book on Calculation by Completion and Balancing. And this work was on calculations that had many applications in a wide variety and range of problems during that time period, including trade, surveying, and legal inheritance. Algebra is also derived from one of the basic operations in this book, and it discussed the fundamental methods of reduction and balancing, referring to the transposition of subtracted terms to the other side of an equation, and that is the cancellation of like terms on opposite sides of the equation. While many Arab countries were thriving, most of Western Europe was still in the dark. Until two rather important breakthroughs came through. One of these was a man named Pope Sylvester II, or nicknamed Gerbert. He was born in 946, and he died in 1003. He actually became the head of the Catholic Church from 999 to his death in 1003. And he was the first French pope, actually. And he was also the reason that mathematics came back into the time period and into the modern era. He endorsed the study of Arab, Greco-Roman arithmetic, mathematics, and astronomy, and he reintroduced tools such as the abacus and the armillary sphere. He also is said to be the first to introduce the decimal numeral system in Europe using the Arabic numerals. So the abacus was something that he reintroduced into this part of Europe, and its length was divided into 27 parts with 9 number symbols. It excluded 0, which was represented by an empty column. Gerbert could perform different speedy calculations with this, and most of these were way too extremely difficult for people during his day to think through using only the Roman numerals, and that's the reason he brought the Arabic numeral system into that part of Europe. And eventually, by the 11th century, the abacus became widely used throughout Europe. He also brought the armillary sphere back, and he used this as a visual teaching aid in mathematics and astronomy. He would organize the rings and markings on his device, and he found that if he divided it by 60 degrees instead of 360 degrees, it allowed the lateral lines of the sphere to equal 6 degrees. And the polar circle was at 26 degrees, several degrees off from the actual 28 degrees polar circle. The account illustrates that the positioning of the Tropic of Cancer was nearly exact, while his positioning of the equator was exactly correct. So he could use this device to position and accurately portray different degrees. Some of his last armillary spheres actually had sighting tubes, which he fixed on the axes of the hollow sphere. He could use it to observe the constellations, the forms which he hung on iron and copper wires. If he was doubtful of the pole star's position, he could fix the sighting tube into the position to view the star that he suspected was at. And if it did not move out of sight, it was the pole star. He also stated that the North Pole could be measured with the upper and lower sighting tubes. And things such as the Arctic Circle, the Tropic of Cancer, the Equator, and the Tropic of Capricorn could also be measured using different tubes. And last but not least, one of the most important people during this time period of the Dark and Middle Ages, who helped in mathematics is someone we already learned about, and that is Leonardo Pisano Fibonacci. He was born in 1170, and he died in 1250. He helped write a book called Liber Abaci, and in this book, it helped solve different problems that were aimed at merchants, such as during that time period, such as how things related to the price of goods, how to calculate profits on different transactions, how to convert between various currencies that were used in the Mediterranean countries. He was responsible for solving a lot of different problems during that time period. However, what he is probably most famously known for is something we already learned about in class, and that is the Fibonacci number sequence. And he actually he created the sequence, or noticed the sequence from this thing he heard about rabbits. And I'll read it to you now. A certain man put a pair of rabbits in a place surrounded on all sides by a wall. How many pairs of rabbits can be produced from that pair in a year if it is supposed that every month each pair begets a new pair, which from the second month on becomes productive? At the end of the first month, they mate, but there is still only one pair. At the end of the second month, the female produces a new pair, so there are now 2 pairs of rabbits in the field. At the end of the third month, the original female produces a second pair, making 3 pairs in all in the field. And at the end of the fourth month, the original female has produced yet another pair. The female born 2 months ago also produces her first pair, making 5 pairs in all. And the point of this was to see how many rabbits there would be after 1 year. And through this sequence, he concluded that there would be 144 pairs at the end of the year. And the Fibonacci sequence is used today in many different things, and we can see it in many different things as well, such as nature, and flowers, and how leaves grow their plants and everything, things we learned about before. And there's actually a newspaper online that you can look at called the Fibonacci Quarterly, and it is actually a pretty cool thing. And it's pretty much a newspaper that discusses different things based on the Fibonacci sequence and relating to the Fibonacci numbers. And I think he is one of the most important advancements in mathematics, especially during this time period, since there wasn't much math being spread around. So what if things have been different during that time period? Say, what if they hadn't put a ban on Greek mathematics at the beginning of the Dark Ages? Who knows what might have happened? Well, the modern world may have advanced quicker than it had if the focus hadn't been so much on religion and on the church, or if had the church actually educated its citizens about mathematics along with the other things. The people of that time period may have been more educated and studied in the ways of mathematics, geometry, physics, and they may have advanced a lot faster than they had. Because it shows clearly that other civilizations were using mathematics, such as the Islamic ones, and they were advancing much faster than a lot of Western Europe was. So, if the advancements had continued throughout the earlier years of the Dark Ages, who knows what might have happened? We can't really say. But I hope you enjoyed my presentation. Thanks for listening. Bye.